Hello, let's see problem set second, question 9th. The sum of two roots of quadratic equation is 5 and sum of their cubes is 35. Find the equation. Question 9th. Solution. Let alpha, beta be the roots of required quadratic equation. Therefore, from given information, sum of roots is 5, means alpha plus beta equal to 5. Let's call it as equation 1. And sum of the cubes of these roots is a 35, means alpha cube plus beta cube equal to 35. Equation second. But alpha cube plus beta cube equals alpha plus beta bracket cube minus thrice of alpha beta in bracket alpha plus beta. And therefore now let's put these values. Alpha cube plus beta cube is 35 equals alpha plus beta is 5. That's why 5 cube minus thrice of alpha beta into bracket 5. Therefore 35 equals cube of 5. 5 5s are 25 and 25 5s are 125. Minus 3 alpha beta into 5 gives us minus 15 alpha beta. Now let's transfer those minus 15 alpha beta from right to left and 35 from left to right. Therefore, we get 15 alpha beta equals 125 minus 35, and therefore 15 alpha beta equals 90, and therefore alpha beta equals 90 upon 15. 15 ones are 15, 15 6s are 90. Let's call it as equation 3. Now, a required quadratic equation is x square minus in bracket alpha plus beta bracket close into x plus alpha beta equal to 0, and therefore x square minus value of alpha plus beta is 5. That's why in bracket 5 bracket close into x plus alpha into beta is 6, that equal to 0. That is x square minus 5x plus 6 equal to 0 is the required quadratic equation. Question 10th. Find the quadratic equation such that its roots are squares of sums of the roots and square of difference of the roots of equation 2x square plus 2 in bracket p plus q bracket close into x plus p square plus q square equal to 0. Okay. Question 10th. Solution. Let alpha beta be the roots of given quadratic equation. And that given quadratic equation is 2x square plus 2 in bracket p plus q bracket close into x plus p square plus q square equal to 0. Okay, and therefore comparing it with x square plus bx plus c equal to 0, we have a equals, a is the coefficient of quadratic term which is 2, b is coefficient of linear term, and coefficient of linear term is 2 in bracket p plus q, and c is a constant term. Here constant term is p square plus q square, and therefore alpha plus beta equals minus b by a equals, value of b is 2 in bracket p plus q, therefore it will be minus 2 in bracket p plus q, and upon a, and value of a is 2, 2 will get cancelled, 2 ones are 2, 2 ones are 2, it gives us minus in bracket p plus q. Similarly, alpha into beta is c by a, and value of c by a will be p square plus q square upon 2, p square plus q square upon 2. Okay, now let alpha 1 beta 1 be the roots of a required quadratic equation. A required quadratic equation and therefore from given information, according to given information, the roots of required quadratic equation are nothing but square of sum of roots of given equation and square of difference of given quadratic equation. Okay, and that's why alpha 1 will be equals alpha plus beta its square, and beta 1 will be alpha minus beta its square. Okay, and therefore alpha 1 will be equals alpha plus beta its square, and value of alpha plus beta is minus p plus q, minus in bracket p plus q its square. Okay, on squaring, square of negative term is positive, that's why it will be obviously p plus q its square, and beta 1 equals alpha minus beta its square, and alpha minus beta its square is nothing but alpha plus beta its square minus 4 alpha beta equals alpha plus beta its square. Alpha plus beta is minus in bracket p plus q, let's put it in box bracket, p square minus 4 into value of alpha into beta is p square plus q square upon 2, p square plus q square upon 2, 2 ones are 2, 2 twos are 4. Okay, and square of negative term is positive, that's why it will p plus q its square minus 2 in bracket p square plus q square. Okay, and if we simplify it, it gives us p square plus 2pq plus q square minus 2p square minus 2q square. Okay, p square minus 2p square gives us minus p square, then q square minus 2q square gives us minus q square, and rest of the term is 2pq. Okay, if we take minus sign common, then we get minus in bracket p square minus 2pq plus q square. Okay, it will be just like this. Okay, it is value of beta 1. Now alpha 1 plus beta 1 equals alpha 1 is p plus q bracket square. Okay, p plus q bracket square plus beta 1 is minus in bracket p square minus 2pq plus q square. On simplification it gives p plus q bracket square is in the form of a plus b bracket square whose expansion is a square plus 2ab plus b square. Just like that it will be p square plus 2pq plus q square. Now plus into minus is minus. Minus sign will be applied to each and every bracketed term, which gives us minus p square plus 2pq minus q square. Plus p square minus p square will cancel, plus q square minus q square will cancel. That equals 2pq plus 2pq gives us 4pq. Okay. Now let's call it as equation first. Therefore alpha 1 plus beta 1 equals 4pq. Now we need to find alpha 1 into beta 1. Now alpha 1 beta 1 equals value of alpha 1 is p plus q bracket square, p plus q bracket square into value of beta 1 is minus in bracket p square minus 2pq plus q square. Okay, it is an expansion of p minus q bracket square. That's why we can write here again like this. Therefore alpha 1 beta 1 equals p plus q bracket square into another box minus in bracket p minus q its square bracket close. Plus into minus gives us minus, that is equals minus. In box we can write p plus q its square into p minus q its square, box closed. Then it will be like this, minus in bracket p plus q into p plus q into p minus q into p minus q. Okay, we may pair this like p plus q into p minus q and p plus q into p minus q. Okay, and expansion of p plus q into p minus q is nothing but p square minus q square. Yes, it will be p square minus q square into p square minus q square bracket close. Means it will be minus in a box p square minus q square is square, and therefore alpha 1 into beta 1 equals. Okay, equation second. Now we have alpha 1 plus beta 1 and alpha 1 into beta 1. Now required quadratic equation is, okay, now required quadratic equation is x square minus in bracket alpha 1 plus beta 1 bracket close into x plus alpha 1 beta 1 equal to 0, and therefore x square minus alpha 1 plus beta 1, value of alpha 1 plus beta 1 is 4pq bracket close into x plus alpha 1 beta 1, value of alpha 1 beta 1 is minus p square minus q square, its square. Okay, and therefore, or that is, we may write, that is x square minus 4pqx plus into minus gives us minus p square minus q square bracket square equal to 0 is the required quadratic equation.